Hello. So, today we will continue our discussion on computer networks and internet protocols. Today we will be starting our couple of lectures on IP routing. So, already you have seen that how a application layer in our OSI or TCP IP model works. You have already looked into several transport layer protocols and also the basics of IP layer protocols. So, IP as such is IP layer, or it is also known as the network layer, is primarily responsible for forwarding packet from one network to another, right. So, it is if we look at the internet, which is a network of networks. So, the IP layer is primarily responsible for connecting the two or more different network across the thing. Now, one major aspect of this particular forwarding thing is that how the packet will be forwarded across the global internet, right. So, internet as such we have seen having truly speaking that millions of systems, thousands of routers and so on and so forth, right. So, how a packet from one to another it will be getting forwarded, like if you from your system, if you are typing www.iitkgp.ac.in, then the IIT-KGP page gets displayed on your screen. So, how your request comes up to this IIT-KGP web server, and then IIT-KGP web server replies back to your systems, right. So, if you are requesting from a far network, so how it will go on hopping to this router. So, if we imagine a overall internet, or not imagine, if we look at the overall internet. So, there are several networks and there are routers which connects these networks, right. So, routers are responsible for forwarding packets from one network to another network and type of things. So, if there are multiple hops are required, the router should be responsible for doing that, right. So, today or from coming couple of lectures, we will be discussing or different forwarding mechanisms, how the packets are getting forwarded from one network to another network to another network, till then the destination host is reached, right. So, if we look at, we will be primarily looking at following things: IP addresses and address allocation. Already you have gone through that, we will quickly brush up on the things, and we will start looking at packet forwarding or routing, or there are we will say forwarding table or routing table. We will be little bit interchangeably using the tables which are looked at in the router. And there is another concept whenever we come into play, there is the longest prefix match, sometime LPM forwarding, right. So, longest prefix match, and we will be primarily referring this in whole of these lectures or series of lectures. We will be primarily referring some of the books and reference note and reference materials and of as mentioned there, and as we have mentioned in our earlier slides also, right. So, IP address is already all of us, or you know, that it is typically when we as of now we are talking about IPv4. All our dealing of this routing will be primarily based on IPv4. So, it is a 32-bit address with every 8 bit dot 8 bit dot 8 bit dot 8 bit, right, and it uniquely identifies a particular machine, logically provide a logical address to a particular systems which is connected in the internet. In other sense, we can say that two systems on the same on this network cannot have two same IP address, then it will not be able to identify those uniquely, right. But there are way out, still we are having those type of things that will come slowly, but nevertheless we think that this is a logical address which goes to the things. Later on in this particular course, we will look at another type of addressing, what we say physical or MAC address, which comes with the your network interface card, right. So, that is the address by which by the system is identified. So, but this is logically able to identify the systems. So, this IP address is typically provided by the system admin, or in some cases are provided through some other mechanism like DHCP and type of things, right. So, uniquely it identifies an interface on a host, on a router, that is a interface, right. So, where the network is connected, represented by dotted quad notation, right. This is known fact, and everything in the system or the is represented by binary. So, if it is 14, 35, 158, 15, it is represented by like this, right. Now, if we look at internetworking, so used to connect networks together, not primarily networks. So, there are several networks which are connected together. So, we need a way to address a network or group of hosts, right. Like I say that I require IIT Kharagpur as a network. Inside IIT Kharagpur, I may have different sub networks, like say Center of Educational Technology may have a network, computer science and engineering can be a network, administration of IIT Kharagpur can be network, and like that, right. And so, there are several networks, and in other way we need a way to address this network also, right. That means, if I am going from one network to another, I should be able to know that address of the network. As we have discussed at the previous lectures, initial lectures, so this network layer is responsible for routing. That means, for forwarding packet from one network to another, right. Or we say that in other words, these routers are having that layer 3 capability, or it can see packet up to layer 3 or network layer in TCP/IP model, right. So, we have physical layer, MAC layer, and then or data link layer, and then the layer 3, and router can look at the layer 3 capability. So, it can look into the network to network communication, right. So, here also we can say this is a typical one LAN having some host, this is another LAN having another host, and there can be bunch of routers, and we can say this is a something in the intern networking, or sometimes we say there is a wide area network. But nevertheless, what we require that different routers which allows me to connect that. There can be 3, 1, n number of routers which allows to the connect to the network, right, and there can be different other networks which are counted to the network. So, the every router has some interfaces, right. Sometimes we represent by the serial port of this router 1, 2, 3, 4, 1 / like that type of representation. We will see some of those, but nevertheless that router has interfaces. Every interfaces allows it to connect to another router or another network in the things, right. So, the one major challenges in any system is the scalability, right. Like one way of looking at this router is that the router somewhere or other knows that if I get a packet from say host A to host B to be forwarded, A to B or say A to B or C to D to be forwarded. So, the router knows that if from here it is generated, then where it should be forwarded, which router to be forwarded, then from where it is to be forwarded, and so on and so forth. That means, there should be somewhere what we say some sort of a lookup table. Router looks at a table and see that, oh, this is the packet, so forward this to the things, right. The problem becomes that any system added or other sense deleted from any of the network needs to be again the routing table needs to be updated across the all network, all routers across the world. Otherwise, it will not be able to forward packets, right. So, there should be some mechanisms that we will see slowly, that how to forward these packets from one to other. Now, if we holistically try to look at a router is primarily it gets something from one interface, looks at the destination where it should go, consults its some table or some information and say now you go to that to this particular through this channel, right. Or in other sense, if I try to make an analogy, like I want to go from here to say Nasik and then try to go a major corner, I ask that traffic fellow, now I want to go to this Nasik, this near, then which way you go? He has some information that in order to go that it has to follow this path, then go and meet at the next traffic person and who will redirect, etc. So, it has some informations which allows it to route it. So, what in other sense what we say, these are the router maintains a table which is called routing or sometimes forwarding table, which allows to forward these things to the destination, right. And this how this table will be constructed, how this table will be maintained, that is another challenge. But nevertheless, having this table will be pretty large, considering the number of networks and routers and in our internetworking. And as we understand, this is very dynamic, because we do not have any control or there cannot be a overall centralized control that how many networks etcetera there, and not only that, there can be more systems coming in, going out, more network being generated. So, it becomes a major challenge in routing the packets. Right. So, every router needs lot of information and to know how to direct packets towards the host. So, divide the network into host portion is the first thing what we have seen, right. So, if I have have some hierarchical sort of things, or I divide that, it is a host portion and a network portion and by a host portion, right. And that already you know that there is a net mask which allows that if I mask it, and then so net mask is a mask which followed by it is also a 32 bit number or 32 bit address, where it follows by a series of 1 and then a series of zeros. So, there cannot be in between 0 1 type of things, right. So, it is series of 1 followed by things, it mask it, and whatever it mask it out, it is the network address, right. So, like here what we say 24 bit address /24 representation. So, the first 3 octet they represent that network or the 24 bit network, and rest is the host of the thing, right. And if you try to look at something analogy with our postal mail system, also we have different category of the things, right. We have say country, state, district, city, then maybe a area location, and then the house address and type of things, right. So, if I want to mask that whatever is for West Bengal, say West Bengal India, I can mask it and segregate. I can say Kharagpur, West Bengal, India, segregate, then IIT campus, Kharagpur and type of things, and so on and so forth. So, it depends on that how. So, there is some rough. So, what we can say, I can approach the problem in a hierarchical way, right. So, I can make a hierarchy that a given address. So, this is the network address and type of things, right, and this is typically a mask of 25 bit, and if I mask it out and you get that IP address, that already you have seen, right. So, in other sense we have improved some sort of a scalability, like I can say that this is I identify that particular with respect to a network address, and now with the LAN 2, if this was the way it was, the table was maintained in this router, that this way incoming with 24 bit, whoever is matching will be coming here or going out. So, in the LAN 2, if I add a new host, so you does not require adding a new forwarding entry into the table. So, it now does not address host by host, but address a network. So, this network what we see is 5670 /24. So, it is a network address is with 24 bit mask, and if I add something like this, I do not require that all these routing things individual routers across the world need to be changed. Still it is in the same network. In other sense, this this way of representation allows me to identify a particular network through a identifier, right. So, I mask it and this network has this network address and forward that, and then rest is the host address will be inside the thing, right. Now, so this way we can look at some way of addressing the scalability issues. And then if we look at the IP address allocation, again you have gone through that, you know those things, but just to again to brush off. So, one is that we have some fixed address allocation, or we say class full addressing, right, like class A address which starts with a 0 and star, class B address 10 rest anything after that, class C address 110. There are two other, one is for multicast group, another is a reserved for future use, right. These two other addressing schemes are there. These are class full addressing mechanisms, or in this case we have a very large block of /8, the network number of network is less, whereas the number of hosts are much larger, whereas in class B it is /16. So, it is somewhere, it is something large, number of networks are with first 16 bit representation and rest are with the number of hosts, and 24 is where number of hosts in these organizations are much less, that 8 bit is there, and there are two multicast things. So, as we know that this type of addressing or which addressing you will choose based on that what sort of requirement you are having at your organization level, right. And then we have also seen that classless interdomain routing, where instead of this class full we represent by an IP mask, right, of any variable length, again followed by ones and then zeros. Like here we say that 12.4.0.0 with a mask of /15 and can be like this. So, that first 15 bit represent the address and the rest represent the host, like here what we see, right. So, may not be the figure fitting properly, but first 15 bit and the rest is on the host side. And in other sense, if we can see that if I get this sort of things, then I can go on dividing them into different subnets, right, or sub networking. In other way, we can have a better manageability of the things in a hierarchical fashion, right. So, prefixes are key to the internet scalability challenge, address allocated in contiguous chunks, prefixes, routing protocols and packet forwarding based on these prefixes. So, the while we route between these addresses. So, I can have different hierarchy of this sort of mechanisms, right, and this is the and I can manage IP in the whole IP things in a better way. Not only that, I can manage the routing information or the routing table or the forwarding table in the router in a much efficient way, right. Otherwise, I need to have all the things into the things, like think of again may not be very strong analogy with the postal, but think of that I have to keep every post office need to keep individual address of rest of the world or even rest of India, right. So, if I want to send a message to XYZ at somewhere Nasik, then I need to know that where to send. Instead, I divide it that if I am sending something to IIT Kharagpur, so it is a state of West Bengal, then district, a particular district, then particular city, then particular area of that city, and then the thing. So, I divide into different stuff. So, similarly, here also we have that type of we can divide them into this sort of things. These are already you have studied in your IP address allocation, etc., but we can utilize this phenomena for our routing. So, so we can have aggregation of the things, like if there are these different networks, then I can have a aggregated network. So, I have 201.0022.24.24.23 type of things, then I can have a aggregated network of 201.10.00/21, right. So, routers in the rest of the internet needs to know to reach only 201.10.00/21. Rest are handled at the lower level, at the inside that particular domain. So, the provider can now direct the IP packets to the appropriate customer. Okay. So, if the provider has these are the customers, right, routers only need to know this higher level IP only, right. This can have different. So, this if this is a some sort of a IP ISP provider, so its customers things are handled like this, right. So, but there are challenges in aggregations if there is scenario of dual homing or multi homing, right. Like say IIT Kharagpur takes a internet connection from provider 1, another connection from provider 2, another connection from provider 3, then that particular network has different multi homing things. Then then I cannot identify this overall aggregation by a simplified thing. So, I need to work on some other things. So, there are challenges, but nevertheless there is a way to aggregate this sort of IP addresses, and then my load on this routing information on routing table can be reduced. So, as we are discussing, the scalability through hierarchy is one of the way we handle. So, the hierarchical addressing critical for scalable systems, do not require everyone to know everyone else for that matter, because it is only the hierarchical and the end router needs to know, or the intermediate router rest of the things. Reduces amount of updating when something changes, right. So, if something changes, it reduces the amount of updating in the things, right. Like as again try to put on the analogy, if the number of quarters in IIT Kharagpur increases, the address need not to be published to whole rest of the world, right. It is only the IIT KGP post office needs to know and update it, and all the packets comes to it and it gets displayed or type of things. And if there is there are non-uniform hierarchy useful for heterogeneous network of different sizes. So, either it can be uniform or non-uniform. Initially class based addressing was fought to courts, because the addressing what we have a class full type of addressing. So, CIDR helps it in that, but it brings its own challenges in handling those, that we will see. So, we can have a block of addresses, the separation of control, prefix assigned to a particular institution, addresses assigned by the institution to the host. Like IIT Kharagpur, it may have this is the network address and this is your host portion. How you address the host portion is basically determined by the institute network administration, right, or the institute network policy, how the things will be there. For the rest of the world, the network IP IIT Kharagpur network is like this, right. So, it helps. And who assign prefixes in a at the top level, there is a consortium or association called or Internet Corporation for Assigned Names and Number, ICANN, allocates large address blocks to regional internet registries. So, registry which maintains the IP blocks, regional internet registry like ERIN, we have an American registry for internet numbers, allocates address blocks to their regions, allocated internet service providers, and there are ISPs allocate address blocks to their customers, who may be in turn allocate that to the customers, and so on and so forth. So, there are several address registries, and there are several address registries which maintains, like who is in registry.in is in the Indian context. There are domain white pages will show you some of the things, where if you give the address, who is the owner, etc., it displays the things. Now, definitely whether it is 32-bit address is enough or not, that is a serious question with huge number of devices or network connected devices in place. This is a major challenge, and we have IPv6 and so forth. Already you know a overview of the things. So there are several long term solution of IPv6, and short term we can have private addressing scheme, right. These IP addresses, private addresses are not non-routable addresses, like 10 dot start dot start dot star, this type of addresses are non-routable. So, within the thing, so I can have some mechanisms called network address translator, which translate to a public IP and goes and type of things. There are way to dynamically allocate addresses, that you know, that DHCP type of things. So, those are solutions which are available on the IPv4. So, there are several other challenges in the IP related, that how much address space per geographic region, address space portability, whether you carry over the address space, keeping the address registry up to date. There are several challenges. There are what we say so called quote unquote hard problems, which are people are looking at work it. Now, if we with this context, if we try to look at that packet forwarding, so what we try to say, that each router or layer 3 enabled devices which connect networks has a has some informations or forwarding or routing table which maps destination address. So, router what it is getting, a address for the destination, like if I say www.iitkgp.ac.in from this particular machine, or IIT www.nptel.in nptel.ac.in from this machine, it goes to the nearest router and it looks, the router gets a destination as nptel.ac.in, and it tries to find out that where this IP is there. Either the information should be within, or it should know that where should be my next hop, right. Nevertheless, it takes up, it looks at the lookup table or what we say forwarding table or routing table, and sees that what is the next hop. So, the router in other sense has to maintain this table, right. Anything it gets in one interface, check the table and send that appropriate interface, right. If it is not in that table, so there is a concept of default route. If it is not finding on the table, by default it will route to that particular interface, right. So, upon receiving, inspects the destination IP address in the header, index into the table, determine the outgoing interface, forward the packet to the interface, right. And they are in some situation it can change the some update the header, that will come later, right. The next router in the path repeats the thing. So, it goes on hopping like that, right. So, it checks and go to the through the hop, like here it gets a, if the router forwards a as per IP match destination incoming packets, forward the table entry to determine the outgoing interface. So, it goes on forwarding the table one after another, right. Here /24 is the IP is the mask. So, that means it gets that first 24 bits is the network. So, if it gets a packet like this 1.3.24, it forwards out here this, or it gets that 5.6.7.0/24, that if this is the network address is forward here, right. Now, I can have separate entry for class full type of address. Each router had an entry per class full prefixes, like mixture of A, B, C addresses, depends on the first couple of bits on the destination, as we have seen in the class full addresses. So, identify the mask automatically from the address, like if it is bit is 0, the mask is /8, 10 mask is /16, and 110 the mask is /24, right. Look at the forwarding table of the match, and then it goes on the onto the things, right. Now, CIDR complicates the issue, right, because now it has any type of mask, right. So, CIDR allows efficient use of the limited address space, that is absolutely fine. The address space is not wasted, or I should say efficiently used, but makes the packet forwarding much complicated, right. Forwarding table can have many matches, like 2010.10.00/21, 2010.6.0.23 can have more than one matches. So, where it will forward? So, that is a challenge. So, the policy it is followed is the your longest prefix match. So, where the longest prefix is matched, there it is forwarded, right. So, like here in this case, it needs to be forwarded at 201.6.0 because that is the longest prefix which match, whereas others can have a much less prefix, that is there is the longest prefix which matches, right. So, that way it takes care of the thing, right. So, forwarding table in IP router. So, map each IP prefix to the next hop or links, destination based forwarding, packets as a destination address, right. So, when I am sending a packet, the packet has a destination address. So, when I am saying www.iitnptel.ac.in, so www.ac.in has a after DNS resolution IP, which is the destination IP for my packet. The router identifies the longest matching prefix, and some algorithms should have to look up on the things, right. So, routing and forwarding table. So, I have that destination addresses and it goes on to the lookup tables. Now, it is what it does a maximum prefix match. So, though this up to 201.10 and these are both are matching, but the maximum prefix match says that the other destination this need to be forwarded out to that 10.201.10.6.0, right, and which is connected to serial 0 or some particular interface of the router, outgoing interface of the router. So, now that is the longest prefix match algorithm is maybe as or simple or complicated, there is a major challenge, because that itself a major time. So, the router may have a huge number of entries, like the scan and forwarding table, one entry at a time may take a huge time into the thing. So, that it requires some better algorithm to handle this. Like there can be huge entries like 2 lakh, 2 lakh, 3 lakh entries into the overall entries, and looking at in a linear time will take a huge time, whereas the packets are being pumped into the router maybe every nanosecond, right. So, it is huge number of things need to be processed. So, we need to have a better algorithm to find out this how this longest prefix match can be done. So, that is a major challenge. So, these days it is hardwired, it is handled to the hardware. So, one very traditional way of looking at it is this Patricia tree, where it is in this case it is a binary where you have 0 and 1 and type of thing. So, 1 bit for each level of tree. Some nodes corresponding to varied prefixes which have next of interfaced on the in a table. So, wherever the match goes, it goes on, but in some cases it may not be very efficient, because the tree can be skewed and large number of entries can be there and type of things. That we can have a some faster lookup by having instead of binary k-array type of tree where things can be there. Much faster lookups, and these days there are use of special hardware like content addressable memories CAMs also looks up at the tree rather than the flat type of addressing in looking at the things, right. So, there are efficient technologies to look at, but the basic philosophy it need to search that longest prefix match, right, where it needs to be forwarded. Now, where do the forwarding tables come from? So, routers have forwarding tables may map prefix to the outgoing links. So, how does this forwarding table are where it will come? Either it can have a some sort of a static entry and type of things, right. So, it says that map so and so to this particular serial port, but this is may not be adaptable, right, to failures, new devices added, new devices taken out, then you need to intervene, right, and in some cases there are issues of load balancing, right. So, they are then the concept of routing protocols come into play, that how this packets, how do you update this appropriately, how do you update this efficiently, these forwarding tables or the routing tables, so that packets are forwarded. So, these are called routing protocols. We will look into these routing protocols in our subsequent lectures, and the protocols which are being routed through these particular things, what we say, it is a routed protocols, right. So, we are primarily interested in this routing protocols, this is how these tables will be generated, so that the packets can be forwarded, right. And packets forwarded by the forwarding packets forwarded by there is a typo, forwarded by the end devices or the host, like. So, at what we are having at our end is the Ethernet link. This machine has some RJ45 connection to the cable to the next things. So, PC with Ethernet links, laptops with wireless links, does not need to run a routing protocols, right. It forward to that particular local or the next hop, whatever the gateway is defined into the things, right. So, packet to the external host to a particular gateway, where this gateway is defined, it is defined in my own TCP IP properties or the network setup, and how this information is learned, that where the getter and where to forward, that is either it is statically it has learned, my system administrator told that you configure like this, or there can be a DHCP type or dynamic host configuration protocol, that which allows me to dynamically configure these protocols to be there. And finally, how this packet is delivered at the end host. So, at the end, finally, we will see subsequently that whenever say router forwarding to a router forwarding to a particular host or whatever it does, there should be a resolution to the MAC address, right. So, finally, it should find out that what is the next hop MAC address and deliver the things. For that, we require a protocol called ARP, address resolution protocol. So, there are some address called MAC address, as many of you know, that is the hardware address which comes with the network interface, and in order to resolve this from IP to MAC, we require a address resolution protocol. So, mapping MAC address to and from IP address or ARP and RARP, reverse ARP type of things. So, we have this type of addressing scheme. So, finally, what we look at that IP addresses and different allocation quickly already you have known, and seen that that packet forwarding based on the IP prefixes, right. So, looking at that routers how it forwards, and what we look at this longest prefix match when there are more than one matching coming up, that where the longest prefix match is there. So, with this we conclude our today's discussion. We will continue this routing IP routing mechanisms in our subsequent lectures. Thank you.